Okay, this is lesson 42, and it is pages 96 and 97, and it's called ellipses. Okay, we're going to be looking at the standard form, which means the form that we're going to graph them in, and we're going to look at the things that we actually state about them. So let's go to page 96. I've already got it labeled, lesson 42. Now, in lesson 41, we talked about the standard form of the circle. Now, circle only had one. Ellipses are going to have two, so I'm going to wait and state that information on some Post-its. I have copies from my last year's notebook. I don't have the originals with me. I will give you these Post-its when we get back to school, so you can get the information off of them. You can look at them, pause, when you need to go back and look, because all you're going to be doing is taking these and looking at kind of the format of it. We're going to do two examples, and you have what we call vertical and horizontal ellipses. So let's see, the things we stated. We did standard form, but down here we added that they had an x squared and y squared. They were added, but the coefficients will be the same. Now, the difference with this is they're going to have an x squared and y squared. And to make sure I have enough room, I think I'm going to be good. So I'm going to put that here. I'm going to put they have x squared and y squared. They are added. And what makes it have this unusual shape, this oval shape, is that the coefficients will be different. But the coefficients are not going to be written right in front of them. And I'll show you what I'm talking about here in just a second. Okay, so I'll have these two Post-its for you. And this is the horizontal one. And again, it's already written on because this is from last year's notebook. And then let me get you the vertical. Okay, now I wrote beneath them the standard form, and I want you to look at it. It looks very much the same because you've got x minus h squared. Now, instead of having a coefficient out front, the coefficient is actually 1 over this number right here, but we just write it underneath it. And then the y minus k squared. And then notice the only differences in these, you've got a squared and b squared, and you've got b squared, a squared here, and they're equal to 1. Now, the difference in this is that a squared will always be bigger than b squared. And you're looking for the bigger number is what you're looking for, because that's going to help you decide whether it is going to be horizontal or whether it's going to be vertical. Now, this looks complicated. I'm going to actually put underneath it, you're going to have, they share a lot of the same information, and I think I'm going to go ahead and put this, but you're definitely not going to learn it this way, but I think I'm going to go ahead and state it because just so you have the exposure to it. So if we look at both of these, then together they have what we call a major axis, which is just simply the longer axis, major axis, and they have a minor axis, which is your short one. So we're going to say the center for both of them, and I'm just going to put it in the center because we're doing the same thing, is going to be HK. And you're going to be used to that because that's how you do a circle. And we get the H from the X and we get the Y from the K. So that's pretty easy. And then we're going to talk about the length of the major axis, and I'll show you the abbreviation I use here in just a minute. And you'll also be interested in, if you've got a squared and b squared, what a is and b is, because the length of the major axis is going to be 2 times a, and the length of the minor axis, and that's how I'm going to distinguish them, is capital M and little m, is going to be 2 times b. And then you have the vertices. Let's see how we want to do that. You've got vertices, which are the ends of major axis. Now, they're going to be different for each one of these. The vertices for the horizontal one here is going to be h plus or minus a k. Don't let that freak you out. You're going to see here in just a minute. It's not that difficult. And then the vertices for the, let's see, let's do it like this. And it's going to be h plus or minus b. Oop, I got the wrong letter there. H, and then k plus or minus a. And then you can see that's not the way I learn it. I don't memorize these. And then you have ends of minor axis. And they're called the covertices. And these are the ends of the short one. Okay, and they're going to be h and then k plus or minus b. And then this one's going to be, and I call them CV, covertices, and I actually just call these V, vertices and covertices. And this is going to be h plus or minus b, k. And that's all we're going to graph on them. So, and the really weird thing about it is we're going to actually graph it and then state this information. And that's why you don't have to know these formulas. So just kind of get a feel for it. The main thing is you've got to make sure you know that a squared is bigger than b squared. And I think you'll get that in just a minute. Now, to be able to have graph paper slips, last year I used these. I don't know that I would even use them if we were in class. But if you'll take a slip, and I think you've got plenty, take one slip, and I'm going to, just like your classwork slips, and I'm going to fold it down the middle. And I'm going to cut it in half. And we'll adjust and use one for horizontal and one for vertical. Now, if you happen to have the big grid, little grid, I would use the little grid side. But if you don't have that, I'm going to use the big to show you that it will fit. So, our first one is going to go up here, number 1. Let me get over here. I'm on page 97. And we're going to do x squared over 16 plus y minus 3 in parentheses squared over 9 equals 1. Now, I know it's a ellipse, not a circle, because the coefficient, it's got an x squared and it's got a y squared. If I pull that out, it's got addition. But this has a 1/16 in front of it, and this one has a 1/9. And so that's your coefficients that are different. And then notice the format's a little different. With circle, you had a number over here. You took square root for your radius. This will be a 1. And then that's the algebraic setup, which we're not going to do. So we're just looking at it once it's already set up. Now, you're looking for the biggest of the two. So this one is the biggest. That's going to be your a squared. And then this is your b squared. And because now here's where you got to watch. The biggest one is under the x's. Now think about it. You've got an x and y axis. And if it's under the x's, then it's going to run horizontally on the x-axis, or at least in the vicinity. It's going to run long in the horizontal direction. So I call this a horizontal ellipse. Now, go back over here to this, and I'll show you x minus h squared. Notice that the a squared was the biggest. I'm just going to say largest. So, and if you want to write these down, go ahead and write them on post. If you want to pause it, then I'll come back to this one. But that's really all we're going to refer to it. This is the biggest one. So here's what I write on my paper. I write that a squared equals 16. So that means a equals 4. And a squared equals 9. So let's try that again. B squared equals 9. And B equals 3. And we're only doing integers. I'm not giving you crazy arithmetic. The center, and I'm just using C for center, like we did in circle, is going to be the opposite of what's added in here. Well, we know when there's nothing added, that's 0. And the opposite of -3 is +3. And I'm going to put the positive there for emphasis. So, because it is horizontal, we're going to run our paper this way. Now, when you get ready to do your classwork, I don't think you'll have trouble with either way if you have the full slip. I think you'll be fine running all of them. I can look at them, make sure, but I think they can all run the same direction, and that's fine if they don't. You can actually turn your paper whichever way you want to. Now, my center is going to be 0, 3, which is going to put it up a little bit higher, and it's going to be longer horizontally. So I'm going to, because I know what this one's going to look like, and when you cut this in half, and I think I have a ruler, all you need is a straight edge of some kind, and I had one. Here it is. You can use any kind of straight edge. I'm going to drop my x-axis down a little bit because I know how tall this is going to go. So I'm going to drop it down about as far as I can. And then I'm going to go up. I'll need at least 6 up. So you can kind of eyeball that and take it all the way up. And you could even drop your x-axis down a little bit more. Shouldn't be a problem when you do your classwork. And so the center is right here, which is 0, 3. That's our center. Now, here's what you want to look for. You want to look at your A and B because the length of your major axis, and usually, I'm going to just go ahead and start abbreviating that. I put L of, and then I put capital M, A, length of major axis. It's 2 times A, which would be 2 times 4, which is 8. The length of the minor axis, now that's just my abbreviations. I don't know that anybody else uses it that way, is 2 times B, which is 2 times 3, which is 6. Now that means this thing is going to run 4 this way and 4 this way. You're going to go A, and then you're going to go B, B, and that's what makes it longer. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. I'm really just using my A and B. I'm going A this way. I'm going A this way. So that's like negative A, positive A, B up, and B down from my center. Now, connecting it, it's probably easier than a circle because it is more oval. It's not really a football. It's not pointed. I call it kind of a squish circle because it doesn't have a radius consistent that's same all the way around. It's going to have a short distance and a long distance. Okay? And all you have to give me is the, and I hope I'm going to have room. I may have to trim that just a little bit. I'm going to try to get it all on 2 pages. So I've got the vertices, and I've got the co-vertices. Now these are easy to do, and you don't even have to use those formulas over there because your vertices are at the end of the long axis. And so you just do your points. I go negative 1, 2, 3, 4, 1, 2, 3. So I've got vertex at negative 4, positive 3, and I've got one at positive 4, positive 3. And then my co-vertices are the end of my short axis. So this is 0, 0. And then this one, there's our center, which was at 0, 3. And then this is at 0, 6. And there's your graph. So if you can either fold it down. I'm going to take it and trim it just as much as I can to get it on my paper, because I really, really don't want to do page 98 if I can keep from it. I believe in classwork, I either gave you 6 or 8, and I think you have 4 of each.